Hey guys, so let's talk about number 4, which is one of the ones that on this review sheet you guys said you might have some trouble with. So we have this triangle ABC, and we want to put we want to put point P somewhere on the segment AC, such that when I connect it to B, those two lines are perpendicular. So like if I put P in here somewhere and I draw it to B, these lines will be perpendicular. So P is really the intersection point between AC and that line PB. So let's write the equations for those lines. So if I write the equation through the line AC, the two things that I need to write the equation of a line are a point and a slope. Well, I could pick the point A, or I could pick point C, and either one of those could serve as my point on that line, so I'll use 112. And then the slope for this, because I have it kind of on a plane, I could use my slope formula, or I could just kind of count 1, 2, 3, 4. So down 4, and then over 1, 2, 3, 4, 5, 6, which can reduce to negative 2/3. So now that I have it in point slope form, I can write the equation of my line. Y is equal to negative 2/3 x minus the x value plus 12. I feel like I was yelling over that music. So now we need to write the equation of the line through PB. Again, we need a point and a slope. We know that B is on this line, and B has coordinates 3, 6. And then the slope, because it's perpendicular, the slope will be the opposite reciprocal of the slope through AC, so 3/2. Right in the equation of the line, y is equal to 3/2 times x minus 3 plus 6. And since we're looking for the intersection points between those two, we can take the y value of one line, and we want to know when is it going to be equal to the y value of another line. So when is it going to be equal to this? So we'll set those two things together. Give myself a little bit more room here. That's a 3. Okay, so now there are these fractions, and there's no right or wrong way to do this. We can distribute through now and solve. But I think it's easier to get rid of these fractions. So I look at my denominator of 3 and my denominator of 2. And the least common multiple between 3 and 2 is equal to 6. So let's multiply everything by 6. 6 times negative 2 is negative 12, divided by 3 is negative 4. 6 times 12 is 72. 6 times 3 is 18, divided by 2 is 9. And then lastly, 6 times 6 is 36. So this is helpful because now we don't have any more fractions and I can just kind of solve. So let me change up these colors here. Now I have to distribute this 4 through. So minus 4x plus 4 plus 72. 9x minus 27, I distributed that through, and then plus 36. We see that there's some simplification that we can do on this side. We can combine these like terms here and can combine these like terms here. Negative 4x plus 76 is equal to 9x plus 9. And it's up to you guys how you want to, combine your like terms. I usually like to try and keep my coefficients positive, so I'll add 4x to both sides, subtract 9, and I get 67 is equal to 13x, and then x is equal to 67 over 13, which is like roughly 5.15 or something like that. So now that we know what x is equal to, we can go back to either here or here and find the y value of that point. So if we go back to, let's say, the red one, that second one, y is equal to 3 halves times x minus 67 over 13. Doesn't matter if you put in 5.15 plus 6. Oops, sorry. X is 67 over 13. Okay. And when we do our order of operations as far as PEMDAS, we get 120 over 13, which is approximately 9.23. So point P has coordinates 5.15, comma 9.23, or if you left it in exact values, which I'll show you guys how to do tomorrow, 67 over 13, comma 120 over 13. All right, hopefully this helped. We'll talk about it tomorrow. Let me know if you have any questions.